So can you use L'Hopital's rule? Why can you use L'Hopital's rule? Okay, so then use L'Hopital's rule and go ahead. So I'm gonna give you 3 minutes. And I'll put the other problem on the board in case you didn't copy it all. All right, can we use L'Hopital's rule? Yes or no? Why? Can we use L'Hopital's rule? Poll? No, we're not gonna do a poll. On election day, we ain't do no polls. No, because it will keep getting the original function. What do you mean? What are the hypotheses of L'Hopital's rule? When are you able to use L'Hopital's rule? All right, L'Hopital's rule says I can use it if the top and bottom have limit 0 or they're both infinity. So what do you actually get for this then? Do you get 0 over 0 or infinity over infinity? Do you get one of those two? Yes. Right. So we have the indeterminate form infinity over infinity. So we use L'Hopital's rule. Now Jessica was very clever. Jessica didn't answer the question, can we use L'Hopital's rule? What question did Jessica answer? Jessica answered the question, should we use L'Hopital's rule? Which is a different question. Well, The answer is no, you should not use L'Hopital's rule because L'Hopital's rule is completely useless. When you take the Jessica says when you take the derivative by using L'Hopital's rule, you'll get the original function, meaning you can't find the limit using L'Hopital's rule. So let's see what she means by that. So for the top, I'll just write as x squared plus 1 to the 1/2. This is all over x. So I know I can use L'Hopital's rule. Right? L'Hopital's rule says you're allowed to use it. So I'll derivative of top and bottom. So the top gives me 1/2 x squared plus 1 to the negative 1/2 times 2x by chain rule, and then all over 1. But then what happens? If I simplify this, right? First of all, the 2's cancel out, the x is up top, and I have x squared plus 1 to the 1/2 down below. So all that has happened is the numerator and denominator have switched places. Now, strictly speaking, it's not the same function quite just yet. So can I use L'Hopital's rule a second time? The answer is yes. I still get infinity over infinity a second time. But as you can imagine, if you do L'Hopital's rule a second time, you're just going to loop right back to the beginning, right? We're going to get 1 up top as our derivative, and the derivative down below is 1/2 x squared plus 1 to the negative 1/2 times 2x by chain rule. So then when I simplify this, I get right back the original function. So L'Hopital's rule is completely useless. I mean, L'Hopital's rule does give us some information. It tells us that this limit and this limit, if they exist, are equal to each other. And because those are reciprocals, that means essentially the limit I want is equal to its own reciprocal. So L squared equals 1. So L equals 1 or L equals -1. So L'Hopital's rule does tell us something. It does tell us if the limit exists, it has to be 1 or -1. It's one or the other. So in this case, we're going to get 1. But if I had done x going to -infinity, I actually would have gotten -1. So again, L'Hopital's rule doesn't really tell you anything. And it doesn't even tell you whether the limit exists. So it kind of begs the question. So if L'Hopital's rule is useless, so L'Hopital's rule gives us an endless loop. So what do? What do we do? Where is your precious L'Hopital's rule now? Does no one remember how to do this? Solve normally? What does normally mean, Jacqueline? What does that mean, normal?
I factored out like x squared and then in the root and then solved that way.
Okay, so we're going to use techniques from section 2.4. Now, I won't go through all the little nitty-gritty details. This is from like the first exam or something, or the second exam. And I believe I actually did do this exact example in the notes. It may have had some coefficients on it. But the idea here is, recall, if x is going to infinity, the better thing to do is to factor out the x squared. So if I factor out the x squared, remember it comes out of the square root as absolute value of x. So I get absolute value of x over x times 1 plus 1 over x squared to the 1/2, right? So that's the algebra here. And then since x is going to infinity, the absolute value of x is actually just x. So that cancels out. And then I can see here, I just get 1 plus 0 to the 1/2. So I just get 1, right? So again, the details here are, I'm leaving them out, but we've seen this a lot of times before, right? Since x is going to infinity, absolute value of x equals x. Hence, absolute value of x over x equals 1. All right, so we've seen this a bunch of times. The whole point of this exercise now is just to show you that even though L'Hopital's rule is applicable, it's of completely no use. So you cannot forget all of the old techniques we taught you for computing limits. L'Hopital's rule is powerful, but it really doesn't catch everything.